Hello, beautifuls. This is Atleen, and I'm coming to you with another video. Okay, so as you can see with the title that we're going to discuss straight cables versus cross cables, and I will start. Okay, so if you have connected a laptop, computer, or a desktop computer, or any other device to an Ethernet network, then you may have used a straight through cable. And as you can see, this right here is an example of a straight through cable. So we will sometimes call these patch cables, and they are the most common cable type that is useful in an Ethernet network. These are usually useful to connect devices like laptops and desktop computers directly to a jack or directly to an Ethernet device. And when we began to look into the cable and look at both sides of the cable, we will notice that the wiring in the cable has specific coloring. This is specific colors. So these is color codes, specific, particular colors. And if you compare the two sides, you'll note on the straight through cable that the wires go straight through, and the cable that the wires go straight through, and that is the wire on one side connecting to pin 1 connects on the other side to pin 1. Pin 1, pin 1, pin 2, pin 2. So connecting pin 1 connects on the other side to pin 1. Pin 2 connects to pin 2. Pin 3 connects to pin 3, and so on. All the way through the 8 conductors inside that cable. And that is a straight through cable. Why it's called, that's a straight through cable. There's no changes inside of this. You don't go from one pin to another. Everything goes directly through the cable from one side to the other. So everything is the same. 8, 8, 7, 7, 6, 6, 5, 5, 4, 4, 3, 3, 2, 2. So we often use the straight through cables when we connect up the devices, and yet it won't appear obvious when we look at the ports on an Ethernet device. There's two different kinds of ports in an Ethernet network. One is called an MDI, which is media dependent interface. And this is most often a network interface card. So this would be on the laptop, desktop crossover, MDIX, media dependent interface, MDI. And this is most often a network infrastructure device, like a network switch. Network switch. Once you look at the difference between an MDI and an MDIX, you will see that there are differences on the transmit and receiving side. On an MDI device, the transmits are pins 1 and 2. For the MDIX, the receive is pin 1 and 2. So this is usually how the communication occurs. One device is transmitting, another device is receiving. And if you have MDI and MDIX both connected to one another, you can use a straight through cable and an Ethernet network. We're connecting pins 1, 2, 3, and 6. One, two, three, 6. One device is transmitting, another device is receiving, and if you have MDI and MDIX both connected to one another, you can use a straight through cable, an Ethernet network. We're connecting pins 1, 2, 3, and 6. All the way through that straight through cable. Now, the other pins might be actually connected to pins 4, 5, and 7, and 8. May still be wired inside of that cable, but Ethernet is only going to use two pairs of those, which is pins 1, 2, 3, and 6. And because, and because we have swapped the receiving and the transmitted from the MDI to the index, then you can see to use a straight through cable to go straight to it. And that's why when we connect our workstations directly to a network switch, we don't need any special kind of cable. We just need that patch cable that has that straight through cabling inside of it. If you wanted to connect a workstation to a workstation, that would be an MDI to an MDI. One of the challenges, though, is that our transmits on pins 1 and 2 on both sides. We can't use a straight through cable because we'll be connecting transmit to transmit and receive to receive. And obviously, it's going to get through in that connection. So we also use a crossover cable when connecting one of the index to index devices. Maybe a switch connecting to a switch. So we're bringing up a connection between two switches. For instance, we will use a crossover cable to be able to do this. A crossover cable looks like this. Crossover cable, TIA, EIA 568. This is going to be on the exam, guys. codes are for the TIA EIA 568A of standard. You can see pin 1, instead of going to pin 1 as it did in the straight through cable, is going from pin 1, then crosses over to pin 3, and pin 2 crosses over to pin 6. 3 goes to 1, and 6 goes to 2. As you can see, 1 is going to 3, 2 is going to 6, 6 is going to 2, and I can also show you this in the book. This is going to be in CCNA 200-301 Window Odom Volume 1. And you can also see this in the book on page 44. You can see how the pins 1 to 3, 2 to 6, 6 to 2, 3 to 1. And this will be on exam. So it's good to understand this and understand why it's going to be on the exam. And I can read it to you. A straight through cable works correctly when the nodes use opposite pairs for transmitting data. However, when two like devices connect to an Ethernet link, they both transmit on the same pins. In that case, you need another type of cabling pinout called a crossover cable. The crossover cable pin out crosses the pair at the transmit pins on each device to receive pins on the opposite device. While that previous sentence is true, the concept is much clearer with a figure such as figure 212. And as you can see, this is figure 212, crossover Ethernet cable. Now we're going to go to, do I know this already? And what we just discussed is going to be, do I know this already, is 1 through 6. And what we just discussed is number 3. Which of the following, excuse me, which of the following is true about Ethernet crossover cable? And as you can see, pins 1 and 2 on one end of the cable connect to pins 3 and 6 on the other end of the cable. Thank you for watching. Thank you for subscribing, and I wish you well.